Hi, my name is Adrien Rousseau and I've designed a model of real numbers that go beyond the usual notion of points on a line. Hopefully it could be a useful tool for you to think about numbers. It is based on space, time and theology, and hopefully by the end of this video you'll have understood what I mean by that and you'll have found a new powerful way to think about numbers. So what is space? So if I think about space, I could close my eyes and see three dimensions going to infinity, and you have triangles, you have circles. So in other words, it's the simplest space that we can think of. It's called the three-dimensional Euclidean space. What we need, it's even simpler space than that, because what we only want from the space is that we can find extension in the space. So this is one extension, this is another extension. One thing that we want from the space is that you can join the extensions, which means you have one extension here, you can join it to another one, and it's a new extension. So it refers to addition of extension. So time is a bit less usual, but it can still be explained in terms of simple principles. What I mean by time is you have an extension here. I'm going to mark a sort of very hard boundary that tells you you're in a different space, and now this extension has become maybe this extension. So you have a notion of flow of time, so you have t equals 0, you have t equal 1, and time is this thing that goes from here to here. And it can be specific, you can have different times, so maybe if you arrive at this extension here, it's a different time. It refers to the multiplication. So space-time is what happens when you mix the two. In space you have many extensions and they don't mean anything. They are not really numbers, and you need to decide. Usually you're going to say, well, this is actually the unit. I'm going to call this a unit, I'm going to call it 1. But when you mix it with time, it has a precise meaning. It means you couple this space with the time that is identity, which always take an extension and transform it to itself later. You're going to say this extension here, which I call E, is actually the extension identity, which is both a unit in terms of space and in terms of time. And with this space-time you can add it. It has the property of space. This is E equal 2. But you also have the property of time. For example, if I take this extension here, time 2 will be this extension here, right? And if I take a smaller extension, time 2 will mean this. This is the time that go from here to here, from here to here. So I have both the space and the time embedded in this object that we call space-time. So now I'm going to talk about proper space and proper time. The extensions can be added or multiplied, and so that's useful to think about numbers, because numbers can do both. But you need to have a way to assign a certain time and a certain extension, otherwise everything can be a vast number of different things. So how do you couple space and time, basically? This notation here, it's a bit more complex, but you'll find that it really captures what I mean by space-time, and it's sort of made easy. So one, in terms of time, it is the identity. So in terms of time, it's going to take something and output another thing, right? But since it is identity, it's going to output the same thing. We're going to make it simpler, we're going to represent it a bit smaller. So the identity just takes itself and returns itself. What is this? The same thing. You're going to have 2 arrows here, 2 arrows here, and basically it's going to keep going. And basically when you do that, you're not going to stop. We put it in the shape of pyramid to make it simple, and both in terms of this direction and this direction we make it smaller, so that actually you can have the infinite pyramid, but it stops at some point. It's a finite thing that we can think of. And so what happens here is that you have the whole thing here. This is a unit space. And where do we find it again? Because the pyramid never stops, actually you find another pyramid here, which is exactly the same. So the three pyramid, because they never stop, they're exactly the same. At the top it's the same thing, at the bottom the same thing. The arrows represent time and the pyramids represent space. And what does the identity do? It takes the space of identity, it transforms it into the space of identity. So that's the coupling for the identity here for E equal 1. Let's look at what happens for a number in general. So in general, you have the number x, could be anything, could be 2, could be 3, could be pi. The number x is going to have a time, is the time of x. And to have proper space and proper time, we need first a coupling of the identity. But then to have the time of x, and when you apply into the unit to the identity here, so this is exactly the same object like this, you're gonna get the proper space of x. So the proper space is what happens when you apply the time of x to the identity. What you find here, you find it exactly the same here as well. X, it's the thing that transforms the unit of space into the proper space of x. Sorry. And this is actually a time, but it's sort of a specific time because it's applied to the unit. This is the coupling based on the identity. This is proper space of x. Now we're going to talk about the proper time. The proper time of x, it takes any number that get a certain pyramid as well. So any space, and transform into another space here. And so this is the proper time of x. We sum it here. And what it means is that, as you can see, when we say 2 is both the thing transforming this extension in this extension, or this extension in this extension, that's what we say. You have different space, and they get transformed into another space based on the time 2, which can be applied to many things. So now you have the notion of identity coupling, of proper space, and of proper time. So let's get to theology. So theology is the third ingredient of our model of real numbers. What is theology? So far, we have talked about extensions. Extensions are good, but when you have numbers in space, you also need some signs. You have the positive numbers, you got plus. You have the negative numbers, got a minus. And you have the 0, you can note like this, plus minus. So in terms of time, the positive preserves. Why? Because when you take any sign, so plus minus or plus minus, you multiply it by positive, the sign is going to stay the same. Plus times plus is plus, minus times plus is minus, plus minus times plus is plus minus. So the negative is different. The negative destroys, which means you apply the negative to a negative, it becomes a positive. You apply the negative to a positive, it becomes a negative. So it sort of shifts or destroys. And plus minus, it absorbs everything that you multiply to numbers that sign 0, which is just 0. It's going to absorb the number. So this is for time. In terms of space, when you add a plus, a number with plus, you're going to add. When you use a negative number and you add it, you're going to subtract. And for plus minus, it just does nothing. Then there is the order. So order is a comparison of numbers. And so plus, it orients. And this means that the positives are higher than the negatives. So time is like multiplication, space is like addition, and order is like the ordering of the real numbers. We're going to call that theology because the interpretation in the story is that plus is like good, minus is like evil, and for 0, it's the boundary between good and evil, so you can say it's a boundary. I also think of it in terms of unbounded telesis. You know, 0 is often associated to the origin. Unbounded telesis means that it's literally the origin, so like the infinite potential of creation. This is the interpretation. So now we have all the elements. We're going to talk about the story of numbers. And it's actually a story of creation. Where we are now is that we have space to add, we have time to multiply, we have theology to add all these sign aspects of numbers with the opposites, all this algebra, this notion of groups, but it's a bit all over the place. You don't really know how to map things to numbers. And story of creation goes like this. So first, you're in space, you can choose many extensions. So you're going to choose one extension here. This is extension. You're going to say this extension here is actually the identity. Because you say it's the identity, what you mean is the unit of space, it is unit of time. Because it's unit of time, it preserves. Because if it has a sign minus, it would change, so it would not be the identity. So it's actually 1 and plus. So it has a unit extension, it has a sign plus. Right? And we have time in a story, so we have time flow. We can go back in time. So we're going to change time here. So I'm going to make the same sort of boundary that shows that we're not in the same space. And because the identity preserves itself through time, you can go back to the moment of creation, which means, for example, this is t equal 1, this is t equals 0. Because the identity preserves itself, it can map it back to the same, so it's supposed to be the exact same. This is 1 plus. 1 will be the only thing that exists, t equals 0, which means before any time. So before any time, there's only 1. What it tells you is that it is the identity, and it preserves itself, and its identity of being good, because it's plus. So you're going to interpret this as sort of God. Plus, so it preserves. It is the identity. It preserves good. What happens now? So it is very simple. It starts with God, identity plus 1 and plus. And now, what happens at t equal 1? So at t equal 1, time starts. So now there's no time, because time is like a function that you apply. So at first there's no function applied, so there's no time. Now time is created, and what do you find? So you're gonna have 1, but you're gonna have all the numbers. So all numbers are created, right? It goes to infinity here. You're gonna have all the positives. You're gonna have the 0 of sign plus minus, and you're gonna have the negatives. So this is -1, and so forth. The power of the story here is that you come from 1, so it's a coupling of the identity, and then there is time, and every point on the line, so the infinite line is what is created, t equal 1, every point of the line is just a result from applying the proper time of the number to the unit. So there's a flow, a very clear flow. And so each number here, could be 1, could be 2, could be pi. So this is like 2, this is pi would be over here. Every number has both a proper space, it is just the space that you see here. So it is space in theology because it's also a sign, right? And it has also the proper times that go from here to here. You can talk about addition. If you take a number, if you add it in space, you're going to add the extensions. If it's a negative number, you're going to subtract the extensions. Multiplication, which is just applying this scaling here, you're going to reapply it. It is included in the number as a proper time. And if it's a positive number, it's going to preserve the sign. If it's negative, it's going to destroy the sign, right? So you can talk about addition and multiplication, so you can talk about a field. You can also talk about ordering. If a point is more on the right, it is higher, right? Plus infinity is sort of the highest thing. So you can talk about ordered field. And because it's point, you can also think about sequences of points. You can talk about things such as continuity, more advanced properties of the number. So you have a complete ordered field. And this is really what you gain. You add from these dimensions, by adding this story of creation and these dimensions, you gain the full algebra of numbers mapped into the line. And so that's what I mean when I say it's a model that goes beyond the usual notion of a line, where you don't have this multiplicative possibility or all these things fitting together. As far as theology is concerned, you have many things that help the understanding why is this different than this? Because this is good, so it has a certain multiplicative property where it preserves, right? So it explains things, so it helps map the properties of the numbers onto our model. Of course, you can be cute, you can say things like, well, this is a Father, this is a Son, this is plus infinity, maybe it's the Holy Spirit, because you can say, well, God identifies with all the positives, He creates all the positives. This is His exact sort of image, and this is the creator of all things. So you can start to map things, but the goal here is to have a tool to understand numbers. So by adding meaning, you're going to make dissonant interpretations. You're going to make it harder to think of numbers using this story. The power of having everything together, I'm going to just showcase what you can get. For example, the distributivity of numbers for any x, y, z in real numbers. X times y plus z equal xy plus xz. And by adding all of these possibilities together in a representation, you can say, for example, well, this means that when you apply time to sort of a space, a number is partitioned into two subspaces, well, time going to flow into each partition, and you're just going to join them back together. Distributivity becomes this notion that time flows uniformly into every partition of space. And so you start with this interpretation, which are very consistent with the properties of numbers and can create a compelling story to think about numbers. That's what I wanted to present. Of course, there's more material. We can interpret all the axioms. We can extend this model to complex numbers. But that was what I wanted to talk about in this video. And hopefully you have a nice creative way to think about numbers that is also accurate in terms of the relationship of the objects between them.